Hi everybody, it's Professor McDonald, and in this video I will be continuing Lesson 2. If you haven't seen Part 1 yet, go back and watch that before watching this one. In this section of the lesson, we'll be looking closer at qualitative and quantitative variables in data. Qualitative data are the result of categorizing or describing attributes of a population. Examples include hair color, blood type, ethnic group, the car a person drives. We often represent categorical data or qualitative data with pie charts or bar graphs. The classification of students is the quality or the qualitative variable. The possible data are the answers you could get for your variable. Basically, if you think of your variable as a question you would ask each person in the population or in the sample, you would walk up to the student and say, are you a freshman, sophomore, junior, or senior? You would be asking, what's the classification? And the answers could be freshman, sophomore, junior, or senior, so those represent the possible data values. The proportion, which is a percentage or fraction, of each classification of statistics students is an example of a statistic which comes from qualitative data. Quantitative data are always numbers representing quantities. Remember that not all numbers represent quantities. We talked about Social Security numbers in part 1 of this lesson. Social Security numbers are for identification only. Quantitative data are the result of counting or measuring attributes of a population and can be either discrete or continuous. Discrete data are counts. They can take on only certain values with no partial amounts in between. Discrete data can be finite or infinite. So finite might be if there are only 3 questions on a quiz, then you can have only up to 3 possible correct answers. So that would be an example of where your data would be finite. But the number of chickens are, I meant to say the number of eggs laid by a chicken could be considered infinite, just depending on how long, well, I guess the chicken is going to pass away at some point, so maybe it would still be finite. But I think that the point can still be made. If it's something that can go on forever, then it could be infinite, but they always result from a counting process. Quantitative or continuous quantitative data, so we're focusing on the word continuous here, are measurements. There are infinitely many possible measurements in between any 2 measurements. So examples are amount of milk in a jug, heights, weights, anything you would measure with an instrument, and possibly have very tiny fractions in between any 2 units of measurement. So it's easy to remember that discrete means counting and continuous means measuring. Here's a good example where we see the difference between discrete versus continuous data or variables. If I have if I think of a backpack full of books, we can have a continuous variable or a discrete variable related to those books in the backpack. A discrete variable would be the number of books in a student's backpack. And so the data would be the answers you could receive from each student, 0 books, 1 book, 2 books, 3 books, and so on. Continuous variable example is the weights of each book in a student's backpack. Quantitative data example here represented by a graph called a dot plot. It's quantitative because it's a quantity. We're seeing these average number of hours that a student or a person, it doesn't say student here, average hours sleeping per night. So each one of these dots represents a certain number of hours a person sleeps per night. The data are the answers you could get, or in general, data really means you've collected something and you have the actual values. Or you could say that the potential data answers are any number of hours between, say, 0 to, I guess the maximum could be 24. But the data that was collected for this example are listed here. Quantitative data can be represented like we see it here in a dot plot, or similar graphs such as histograms and other graphs you'll learn about in Lesson 3. The mean, median, mode, and standard deviation are examples of summary or descriptive statistics that can be taken from quantitative data. You'll learn about summary statistics in Lesson 4. So let's look at a few more examples and see if we can determine whether they are qualitative or quantitative. Just based on this graphic, can you tell which type it is? Well, if we look on the horizontal axis, we see that we are recording credit hours completed and the number of students that fell into each category. But the question that was originally asked would be the variable. So based on what the variable is, we'll be able to tell if it's qualitative or quantitative. So what is the question that each student would be asked? The number of credit hours would be the question asked for each student. So this would be quantitative data from a counting process, so it's discrete, because each datum would be collected by counting the number of credit hours each subject is taking. Notice that this type of data, we could calculate an average. Is this quantitative or qualitative? Let's identify the variable, the question that would be asked. So it looks like we're talking about students again as subjects. We have De Anza College and Foothill College, and the students were all asked whether they were part-time or full-time. So the question or the variable is the student's status, part-time or full-time. The question or the variable would be what is your status or what is the status of the student, and the data answers that you could receive would be part-time or full-time. Now, just to talk about a common way of getting a little confused about whether this is quantitative or qualitative is that we see numbers represented here in the graphic. So some students might jump to thinking that these are quantities. They may even start thinking about it being discrete because you're counting the number of students that fall into each category to get a percentage. But it's not quantitative because the question being asked is qualitative, and the data values that we can receive are words, not quantities. Again, here we see that we're recording full-time or part-time. And so this is qualitative, and this is an example of a bar graph. The variable X, the student status, the data full-time or part-time. Again, here we have a bar chart. Now, it's interesting to note that this data does not have percentages that add up to 100%. So there's some kind of overlap happening between these different categories here. And so we could not represent this with a pie chart. We'd actually have to use a bar graph. Sometimes you can use either one interchangeably. For example, we used a pie chart here, and then for the same data, here it is in a bar chart. Now, which do you think creates a better picture? They're both pretty good, but I like being able to see the two colleges' statuses side by side, but they pretty much represent the same thing. But for this data, we could not put it in a pie chart at all because we wouldn't be able to complete a circle. There would be overlap and it would be confusing. Here's another example using a bar chart. And is this quantitative or qualitative? Again, we see on the horizontal axis, we have categories. And so what would be the variable? The variable would be the ethnicity of students, and the data answers you could receive are Asian, Black, Filipino, Hispanic, Native American, Pacific Islander, and white. Right? So the variable X is the ethnicity. The data, Asian, Black, Filipino, Hispanic, Native American, Pacific Islander, and white. Notice that the percentages do not add up to 100%. Again, if you add up these, they are less than 100%. So that means there were some students in the sample that did not identify with any of these categories. So again, we could not put this in a pie chart because we wouldn't be able to complete the circle. The same information is here in another bar chart. The previous example was categorized from by alphabetical order. Here, we have them categorized from largest percentage down to smallest percentage. This creates a really good visual, and we call it a special name. It is a bar chart, but it is a Pareto chart, more specifically, more correctly. I'll show that again, Pareto chart. Here we have the ethnicity of students represented in a pie chart. I thought we couldn't do that. Well, now we can because we're providing a category called Other to account for the missing students that did not respond to any of these or did not choose any of these categories. Here we have CEO's ages. So the variable would be the age of the CEO. And since we're counting years since birth when we record a person's age, that would be quantitative discrete. The data are the number of years since birth. So you could have answers like 40, 41, 42, and so on. Here we have another Pareto chart. We have airlines down here. So is this quantitative or qualitative? Well, look at the heading of the chart, total passenger complaints. So that means the variable is actually quantitative, and it's counting a number of complaints, so it's discrete. So the question that would be asked of each airline would be, how many complaints have you had from passengers in a certain period of time? And because the question asks, or the question that would be asked would receive quantitative answers, this is a quantitative variable. Pareto chart, organized not in alphabetical order, but from largest number of complaints down to the smallest. That concludes lesson 2, part 2. In the next video, I'll be going over part 3. See you there.